Okay, let's do the review for the exam 2. So your exam 2 will cover part of section 2.5, which we didn't do for the exam 1, right? So it includes the exponential function and log function and for the derivatives and chain rule. So those are on your page 44, are the rules for the log and for the exponential functions. Okay, also covers some sections for the applications, right? For the exam 1, we did all the basic skills and tools and first derivatives, right? Then this part, we emphasize on the applications, which we did a few in those sections. So let's do the review for the derivatives first. Okay, so look at your review paper, page 1, first portion. So we do if f of x equals natural log x squared plus 1 to the cube. We say for the natural log, its derivative, just whatever the simple things x inside the log is 1 over x, right? But if your natural log inside is not simple x, then you have to do the chain rule. So f of x is in terms of x place, so that's where you are, 1 over f of x. But we do the chain rule on it as well, then take a derivative whatever inside, that would be f prime of x, right? That's for the natural log. And for the exponential function, and it's a simple one, e to the x, that would be the same thing. However, if the x place is more complicated instead of x, you have f of x, right? Then the whole thing, it should be just like that. So this is e of x, then you will have e of x, e to the x power. E to the f of x, you will have e to the f of x power. Then the complicated part, you'll have what? Instead of original x, you have to do the chain rule on this complicated part. That would be f prime of x, right? Then for e to the kx power, kx in terms of fx place. So that's the same thing, ex, right? But you take a chain rule on f of x, which is kx. So f prime of x of kx would be what? Just k, right? So those are the log function and exponential function. Then we practice the derivative, which we will use later after the exam. Okay, so let's do that. So for the first one, we are going to do the derivative f prime. So your f prime x means what? Taking the derivative whatever for this one, right? Okay, which would be this one and this one, right? So for the log, then you do what? 1 over whatever after the natural log, right? That would be x squared plus 1 to the cube, right? Then, according to the natural log chain rule, then you need to take a derivative of this as well. So that would be what? The top would be d dx for the things inside, right? So according to this, we don't need a 1 there. It's the same thing, right? Then when we do this one, and we need to take a derivative of that, right? So it's what? You have something inside, if like x to the 3rd power, so you drop 1 level, right? So you move that coefficient to coefficient place, then you drop 1 level. However, the inside is not only x to the cube, basic polynomial function, right? And so we use power rule, but inside it's not as simple as that, not only x. So you need to do another chain rule. Right? Then what do we have? We have 3x squared plus 1. Then this one, take a chain rule, will be 2x. Is that right? Then we simplify, right? Square, then this one twice, then you only have 1 left, right? So what's the answer? So that would be 6x x squared plus 1. Is that right? Manageable. So when you do your test, don't forget about your chain rule, right? Second one, and f of x is, let's see, f of x is natural log negative x. It's almost the same, except your what? Inside is not x, it's negative x. Then you have to do the chain rule. Okay, so your f prime of x will be what? D dx for the natural log negative x. Right? Then natural log say it's 1 over, but on top, if inside is not simple one, you need to do the chain rule. So we will do negative here, then we will do the chain rule for the inside, right? Then what's the chain rule for the inside would be? That would be negative 1, negative x, so that would be 1 over x, right? So you should be okay to do the derivatives for the natural log, right? Let's see. Third one, your f of x is what? Ex to the x squared. Okay? So you can do the quotient rule, right? Because it's a division. But I prefer to do the product rule. How about this way? Okay, so if I want to find the f prime of x, that means I'm going to take a derivative for this one, right? Then product rule is easier to remember. You take the first derivative for the first one, right? Times second one, then plus the derivative of second one times the first one. Much easier to remember than quotient rule, but both are relatively straightforward, right? So that would be, I'm going to do the first one times the second one, which is x negative 2, plus I'm going to take a derivative of the second one times the first one, right? This is a straightforward one, direct, right? No complicated things there, so just itself, then times x negative 2. Then this derivative is easy because just base with power, then you move out, then minus, so that will be negative 2, then drop one level times this, right? So the answer would be this way, ex x negative 2 minus 2. I'm just trying to write it a similar way. So you can write the answer as such, okay? But on your paper, I wrote the answer a little bit differently, okay? So you can just do this way. Or if I write this way, I can write ex to the x squared minus 2ex to the x cubed, right? Then I write what? Same to the same denominator, so that would be x to the ex minus what? 2ex to the x cubed, then x cubed, ex minus 2e to the x, right? You can write the answer either way. If you use quotient rule, then you will get this one. But if you use product rule, you probably will write the answer this way. But either way, it's okay. Right? Let's look another one. Okay, so we are practicing the derivative of the log and the derivative of the exponential function, right? So let's do next one. F of x equals natural log e to the 2x. Okay, so we are combining this one. All right, so I'm just thinking something else. Okay, let's follow the rule first, then let's figure out the shortcut. All right, so if you are familiar with natural log and exponential function, you will have a shortcut. Okay, so let's do this one. Natural log will use this, right, with chain rule. So f prime of x equals what? Your dx natural log for the whole thing, e to the 2x, right? Then you do this way, you put everything on the natural log. When I put the things over, just inside, that means e to the 2x, right? Because that's the natural log of the e to the 2x, right? Then we are going to take chain rule for the inside. So you will do d dx for the e to the 2x, right? Then for the exponential one itself, but if more complicated, it's right here. Then you take a derivative of that, it's 2. So you will move 2 outside, e to the 2x, right? E to the 2x. Then you cancel all that, that will be 2, right? Okay, then let's see what it is shortcut. So you can see f of x equals what? Natural log e to the 2x. If you remember your the rule, right? So it can be what? Where is the rule? You need to look at the very beginning on your log. I think it is on the section 1.8. Right? Exponential and log. Okay, we say on your, if you remember, okay, let's see, on your page 17, there is the logarithm property. Okay, so we say, okay, log bm to the n power. You can move the n outside, will be n to the log b to the of m, right? That's power property. We have that. Okay, so whatever the power for the log, right? Same thing if you have a natural log, is what? Natural log is log base e, right? M to the n is same thing, n log e to the n. So I change the natural log, m to the n equals what? N natural log n, right? That means whatever you have a log, you can move your power to outside by power property. So that will be 2x to the natural log e, right? Then if you punch into the calculator, natural log e actually is what? Just 1, right? Because as well, we have what? Let's see. Natural log e is the same thing as what? Log base e, that would be 1, right? Because e to the 1 power is e. So actually, your f of x is what? 2x instead of this big thing. Okay, then you take a derivative of prime of x. That would be what? Just 2. Is that right? So, do you have the same answer? Okay. Whichever it comes to your mind first, either way will work as well. Right? So it's manageable. Let's take a look at the next one. It's a little bit more complicated, but just follow the properties, the rules, plus chain rule. Then it will be kind of straightforward, right? Okay, let's look at the next one. Your f of x is e to the x cubed over 3. Is that right? So which one we are going to use? We use this one, right? So your f prime x will be what? D dx for the e to the x cubed over 3. For the exponential, you do the same thing for whatever you have. Then you do the chain rule for your power. Right? So, this one is very straightforward. What's the derivative of this? You move to the front, that will be, this one is here. Here you move to the front for the 3, right? Then you drop the 1 level, then over 3. that cancel. That will be x squared e to the x cubed over 3. Is that right? So we just reviewed what? The derivatives, right? The first derivatives for the log and for the exponential functions. Good? So for your exam, first part of question will be log and exponential functions, right? From numbers 1 to 3 will be one of those questions. And second part will be optimization. We have been practicing, right? So for optimization, we were talking about what? F prime, right? So when f prime at the point of time, if it's 0, that means what? At this x is c at this point of time, it means what? You have relative maxima or relative minimum, right? Or you have IP points, right? Then we use this first to decide. Then we use f prime prime at this point to decide which one is which. So if it's less than 0, you have relative maximum, right? It's the opposite. So because it's what? Concave down. So relative minimum, you will have f prime prime is greater than 0. When it's IP point, you will have what? F prime prime is 0, right? Or undefined, or doesn't exist. Okay, so we use f prime to decide, make it 0 to find out what point of time you have those different conditions. Then you use f prime prime to check whether or not you have what? Maximum profit, minimum cost, or neither. Okay, but usually we don't worry about this. We practice what? All these things, what we have been practicing. Right? So, and we said how to use these skills to optimize the result we need, right? So the way to do the apps word problem, so we did this in our algebra class, okay? In algebra class, if you were in my 154A class, that's what we did. So how to solve the word problem? First, we will do what? Identify things needed. We need to solve problems. Must have some kind of questions. So for the things we don't know, we use X, right? And we will identify things we needed with what? Only one variable. You don't know how to solve 2 variables, okay? We just do it with 1 variable. Then second one, we will what? Write the equations. Then what do we do after that? We will solve it. That's how we did in algebra. But the same concept for your class, we did this way. Same thing, okay? You will what? Identify things needed, still with 1 variable, okay? Then instead of writing, second step, writing equations, we write a what? we write what? We write the functions, right? So what we do is we just write the function. Okay, instead of writing the equation, we write what? Cost C of x, profit P of x equals, the condition, right? Then third part is same thing to solve it. Okay, by doing what? By f prime is 0, right? And we will check it f prime prime to decide if it's bigger than 0, we have what? Minimum, right? If f prime prime is less than 0, we have maximum. Is that right? So that's what we have been doing. So we will see some examples just by doing that. So if you forget, all you have to do is just figure out what was the question, what do I need to find. Then you will identify things needed with one variable. Even you need 2 things, right? Usually, then because it depends on each other, like price and quantity, they depend on each other. But you only use one variable to identify 2 things you need. Then you write your function, right? Your model. Then according to the conditions given, then you solve by what? Prime equals 0, then you check. Then next one, usually we will have what? Conclusion, right? Or interpretation to figure out what we are doing. Right? Okay, let's review some apps. So for your exam 2, you have 4 problems on the optimization. Okay, look, the first one, it says to maximize profit. City Cycles Incorporated finds that it costs what? $70 to manufacture each bicycle. So $70 to produce bicycle, and fixed cost is what? $100 a day. That's a fixed cost, right? And the price function is what? P of x equals 270 minus 10x. Okay? Well, P is the price, so the function is what? Price in dollars. Okay, it will be 270 minus 10x. At which exactly x bicycles will be sold. Find the quantity City Cycles should produce and the price it should charge to maximize profit, and find the maximum profit, right? So look at these functions. Look at this function, price is function of x. What is your x? Did they say? Then, yes, it says P is the price, X is what? So many bicycles will be sold, right? So we are not going to do analysis, and you can look at your notes. But it looks like, right? If you sell one bike, you will have to $60 for the price. That means you give $10 discount, right? If you think you can sell 10 bikes, is that per week or per day? Must be per day because the fixed cost is per day. So if you can sell 10 bikes per day, you can afford to drop the price $100. That would be $270, right? You probably still wanted to do your analysis then to figure out the relation between, your profit. So between the profit and the bikes sold and the price for the sale, right? Then it costs $70 to produce the bicycle, and with fixed cost and function. So we say, all right, we just use our calculator method, right? So first we will do what? Identify things needed with how many variables? One variable, right? So how many things do we need? How many things we need to find? It says what? Find the quantity should be produced and the price should be charged to maximize the profit, right? Whole idea is maximize the profit. So we need to find the profit, right? For the things we need, how many things we need? 2, right? So you set up is this way. You need 2 things, right? So for the quantity sold, right, will be X. That's your X, right? According to the question. Then you want to find out what? The price, the sale price. Sale price will be this one, right? P of X, that's your Y actually. But we don't use Y, right? So that's your P, price. So first we identify things we need to figure out. Then second one, we will write down function. What kind of functions we need to write? For the question is what? The profit, right? But the profit started from what? Your cost. Then your revenue, right? So your cost is C of X, revenue is RX, right? So we know the profit is what? Your P of X would be what? Your C of X minus R of X. Is that right? So what's your cost? Your cost is what? Your unit price times what? Unit price times how many sold, right? Quantity. That will be your cost. Unit price is what? $70 times quantity is what? Quantity is your X from your setup, right? Then revenue will be what? Your sale price times what? Quantities, right? So your sale price, that's the price to sell, 270 minus 10x, then times x is your quantity. Is that right? So that will be 270x minus 10x squared, right? Then what's your profit? Profit is revenue minus quantity. That would be, that would be where? Okay, oh, this is x squared. That's correct. So this one minus this one, right? And, oops, cost. I need something. I was wondering. Okay, the per day cost besides your produce bicycle, you need to what? Add your fixed cost, right? That would be at what? $100 per day, right? We need to write the information given, right? Then you need to use all of them. Then, oops, I'm not doing right. Okay, what's the profit? Profit should be Rx minus Cx, right? So that would be this minus this would be negative 10x squared plus 200x plus 100. Oh, minus, so it should be minus. Am I right? Do I have any typos? Okay. That's the second step, right? Then next step, solve it and check. By what? By this, right? F prime. So for the profit, you take prime, that would be what? You know how to do it. Negative 20x plus 200, right? Then you solve equals 0, right? Then you solve it. X is what? 10. What does 10 mean for x? What does x mean? Okay, so you want to look back. What is your x? X. Where is x? Here. Quantity sold. That's how many bicycles you can sell for a day, right? But do you get a maximum profit or minimum profit? So you check. Negative 20, right? Doesn't matter what's your x. You got a negative number less than 0. It means what? The profit is maximized. Right? And what condition? When you produce 10 bicycles a day, and so sell 10 bicycles a day. Right? So what's the price? Price would be, oh, that's your, so you find this one, your x. Right? X is what? 10. Then what's your price? So your price will be P of 10 will be plug in here. You give $10 discount for each bike. 10 bikes, $100 discount. So that would be 270 minus 100. So it would be what? $170 per bicycle. Is that right? Then what was the question? It says, okay, how many bicycles will be produced a day here, and how much price will be charged? That would be here, and find the maximum profit. How you going to find the maximum profit? Oh, by your profit function, right? So your profit for what? X is 10, you plug in here, right? That's your equation, and that would be, okay, let's just write it out for you. Negative 10 times 10 squared plus 200 times 10 minus 100, that would be what? 900. So what does that mean? It means what? $900 a day for the profit, right? So besides we did, okay, 1, 2, 3, 4 steps, and also for the apps, we would like to make a conclusion and or interpretations, right? It's better to do it that way. So let's just summarize it. Okay, so let's write the summary. Summary. How about that? Okay, so we say, all right, just to answer the question more completely, right? To describe the situation, you will say, okay, the company should do what? Should produce 10 bicycles, right? A day. That's what we are talking about. And you want to say how many and sell how much? Sell what? Sell them for how much? $170, right? Each. And make to maximize the profit of how much? Profit of what? $900 a day. Is that so? Right? Not too bad. Once we struggle through all the thinking, if we understand how to do it, you can just do it directly. Right? For profit and or minimize the cost. So we maximize the profit and maximize the revenue this way. Right? For this case, revenue may not be maximized because revenue only, right, will not count because the bottom line is what? The profit. If you have a lot of revenue, then but it costs you a lot, that doesn't help, right? You want to what? Maximize your profit. Right? Okay, let's look at the second question. This one, they want to maximize the revenue. Okay? Maybe they don't have a whole lot of cost. That's why. Let's take a look. And it says, Rent a Rack Incorporate find that it can rent 60 cars. So it can rent 60 cars for a rental company, and it charge what? $80 for a weekend, right? So it estimated that for each $5 increase, if they increase this by $5, they will have less customers, I would think. So it will rent 3 fewer cars. So, it's here. $5, okay, increase, it will have what? 3 cars less, minus 3 cars. Right? So what price should you charge to maximize the revenue? How many cars would it rent at this price? So they are not talking about cost, so revenue will be mainly, become the what? It will become the profit, right? So they want to maximize the revenue. So how should we do it? So same thing. First, identify things we needed, right? With one variable. So we set up. So which one is your X? That's the thing you need to think about it. Then here we say if you increase $5 each, you minus 3 car, your last 3 car will be rented, right? So how many $5 you want to charge more, or you actually want to drop the price? That will be -5, right? So we want to figure out what? Your X first. That would be your problem. Okay? So you have to think about it. What's your X? So for this case, we want to set up X is what? If I can set up the X as what? The number of $5 increase. If I can set up this way, then I can answer how much would be the price for the rental, then how many cars will be rented, right? So the rental price will be what? The rental price will be what? It depends on how many increase you have. That's your X, right? So rental price will be what? 80 plus how many X? How many $5 you increased, right? Then how many cars will be rented? That should be what? For each one, you will drop 3 cars. For each one, X of them, you will drop so much. So you can set up this way. Will that be okay? Right? So for this condition, that will be your price. Then price is what? The function of X. It fluctuates with X, right? Then this one will be your quantity. Then quantity will be what? Your from the X. Is that right? Okay. Then second step, we need to what? Write our function. Then you have to think about it, how to write it. It's not that straightforward sometimes. This one is straightforward. Cost, revenue, profit, right? When you buy and sell. This one, it's okay, manageable. So what do you think? Your revenue would be, right? How much you charge for each rental, then how many cars you rented, right? So all you need to do is what? Your rental price times what? Cars rented. That will be your revenue. Would that be straightforward? So as long as you start from your X, then you follow through the thinking for the things you needed with what? One variable. Then for the purpose of to do what? To find your revenue. Is that right? You have to find each. How much you rented to the people for each car, how many cars you can rent, right? So that will be what? 80 plus 5x, 60 minus 2x. So those two things are most difficult for you to organize, right? So then next step is much easier to solve. Solve and check. Right? By what? The derivatives we have been learning. So this one, if we multiply out that would be 15x squared plus 60x plus 4800. Then we take a derivative. Would be what? Negative 30x plus 60. Right? Then we make this one is what? 0. Right? So your x would be what? Is that right? Then we'll check. What does 2 mean? Right here. Because you write it at the beginning, that's what you are working with. Right? Then we want to check this one will maximize your revenue or minimize your revenue. Okay? You need to check. So you do the second derivative. So this one is less than 0. That means what? And this means when you have, that means the revenue is what? Maximized. And at this point, x is 2. Right? Then let's answer the question. We did all the work. We summarized the result as the question asking. Right? It says, okay, what price should you charge to maximize the revenue? How many cars will it rent at this price? So we want to find out what? The price and how many cars rented out. So the price is what? The price will be here, right? P equals what? Each, 80 plus each increase $5 for 2 of them. So you will rent at what? $90, right? How many cars can rent it out? That would be this one, right? Your quantity would be what? You drop each one, you drop how many? 3 cars. What happened? I was thinking 3 cars, how come I write it here? So this should be 3, this should be 3, then 15, I'm just checking. This one's still correct, right? 300 minus 200. Man. Okay, so I was thinking that doesn't look right. So each one is a 3, you drop 3 cars. Right? So how many cars will be rented out? So will be 54 cars rented for the weekend. Right? Not too bad, right? Doing it is not bad at all. So, but you have to think through and connect. Okay? So you will have one of those questions, either maximum profit or maximum revenue, right? Another type of questions we will do is what? Minimizing inventory cost. That's the same thing as your lot size. How big the lot you want to rent it. All right, like a furniture shop, then they have to rent the floor for the show, or the publisher, they have to rent a big place to store their books and inventories, right? So we want to minimize those costs. Take a look at the number 3. Says a toy manufacturer estimates the demand for a doll to be what? So many per year. This is your demand, right? So many. That means what? Quantity. Is that right? Demand quantity. 10,000 of them per year. We are talking about a year. That one we are talking about what? The weekend, right? The previous one, number one, problem one, we're talking about per day for the bicycle. So take a look at the question first, see what, we are talking about. Then each doll cost how much to make? $5 to make, right? Plus setup cost for what? $800 per run. This is a setup per run. Okay? And it costs $4 to store. To store it, $4 per doll. To keep it there for a year. So how many should be manufactured at the time, and how many production runs should there be to minimize costs? Right? So same thing. First, we want to identify things we need with one variable. Right? So let's see. First, we need to identify our X, right? So we want to identify things needed with one variable. So what kind of things you want to use for X? That's kind of, important thing for you to decide. You can set up, the question was what? To find how many production run, right? Or how many will produce at a time. So you can say, okay, I'm going to produce number of the dolls to produce, right, at a time. Okay, so you can do that. Number of dolls produced each run, right? And you also, how many number of runs per year? That's the things we are going to find out. So for two things we need to find out, you can only use one variable. Then you have to decide which one will be your X. You can do either way, actually, okay? So, because if you do this one, it's X, how many dolls per run? Then total will be 1,000. Then you do what? 10,000 divided by what? X, right? That would be how many runs per year. If you do this one is X, then how many runs per year? Then how many dolls will be produced? That would be this one, would be how many dolls produced. Either one will work, okay? So as long as you identify them with just one variable, you set up one as the X, another one you should be able to find out from the conditions we given. Is that right? Right? Then this one is we want to find out what's the cost then we wanted to minimize it, right? So you need to write your equation and function, right? For the cost, then you have to use your thinking to figure out how actually it costs you, right? That would be what? Is what? Cost per run, right? Cost the production each time, then times what? How many runs per year? Is that right? Plus what? The storage cost. Right? Then what's the cost per run? That means what? For the dolls, each one is $5. If you produce so many, that will cost you what? 5x, right? Plus the fixed cost to set up. Then how many runs per year? That's your how many runs per year, right? Then what's the storage cost? Say each one is $4, right? Then depend on how many dolls there, which is X during that time before next run. But we say consider as half, right? Average out. At the beginning is X, at the end is 0, so you average out is half. That's how you set up your cost. Main thing is you need to remember this one cost per run times how many runs per year, right? Then doing the math is relatively simple for you now, right? So we have 8, 0, 0, 0, 0, 0, 0, -1 plus 2x, right? So you set up your function. Then next step is what? Solve and check. Check by second derivative. Solve by first derivative, right? First derivative would be what? Move over, drop one level, right? And take a derivative. That, right? Then you set up equal to 0, then you solve your x. You need to know how to solve that, right? Let's do it one more time for you. So that would be plus 2 is 0, right? Then move 2 over. I have this one. X -2 equals -2. Then I'm going to, let's just change this. X squared becomes, x -2 becomes denominator. Right? Then you multiply x squared, right? Then you have this one. Then you divide it by -2, so x squared is what? 4, 0, 0, 0, 0, 0, 0. Then you take the square root is what? 2,000. We don't use negative, right? So how do we know it's a maximum or minimum? So you do c prime prime x, which is this. That would be what? Negative times become positive, becomes 16, 0, 0, 0, 0, 0, 0, x to the third, right? Then it's the same thing as x to the cube. Then x is positive, the whole thing is bigger than 0. So it means what? So the cost, Cx is cost, right? The cost is minimized or maximized. Greater than 0, opposite is what? Minimized. At what? X equals 2,000. Then what does 2,000 mean? You will do what? $2,000 per production to produce that way. Right? Then let's just summarize what we did. So how would you say it? What was the question? So you will answer the question in a more complete way, right? So those are your work. And to summarize it, so how would you say it? Okay, so you will say, okay, you will produce so many dolls per production, right? Should be manufactured at one time. Total how many? 4,000 a year. And then how many productions run per year? Oh, 10,000. Okay, so and how many production runs you will make? 5 production runs per year, right? For the purpose of what? To minimize the cost. Is that right? That's what we have been doing, right? So if you follow this way of thinking, you should be fine to solve the problems. So you need to set up your X. How do you identify? Then look at the questions. You have 2 things you need to identify, right? Then you said one of them is X. Then another one will be derived from the X with given conditions, right? The next one, you will set up the functions that depend on your cost or your revenue or your profit. You should be able to reason it. That's your business, right? If you want to do business, you better know your costs or your revenues or your profits, right? Then doing other things is just technical details, your skills. Then, what do? You summarize what you have been doing and finalize the thinking according to the questions you try to resolve. Right? Okay. Let's look at the next one. You will have one of those questions on your test as well. We need to practice is elasticity of demand. Okay? It says an automobile dealer is selling cars at a price of what? $20,000. That's too cheap. Must be used car, right? The demand function is this way. This one is per car. Then demand function is written this way, okay? So quantity, demand quantity. So that's your Q, right? According to your price given. So it's telling you somebody did a study, say okay. So that's the demand according to the price. Okay? So P is the price. P is the price, right? Q is your quantity, which is what? This guy, right? According to the price. It says, where P is the price of the car, right? Should the dealer raise or lower the price to increase revenue? So his price, original thinking setup is $1,200. So once we have demand function, it tells you can find the, elasticity of demand, right? So you need to use the formula. Do you remember the formula? Formula is what? The E thing, right? Formula is according to your price. Then we have negative P times D prime of P over what? dP, right? So we say if it's bigger than 1, would you raise the price or lower the price? Or bigger than 1, less than 1, or equal to 1, right? Situation. So we say this one, if end up bigger than 1, it's elastic, we will lower the price. Then less than 1 means inelastic, then demand doesn't, react to the price. You might as well, raise your price to get more income, right? Then if it equals to 1, it means what? You have maximized the situation. Okay? So let's do the E. So E is what? Your E would be plugging here, right? So this is your function. So it's negative P times dP is this one, right? D prime P is what? You take a derivative of that. So let's do that derivative. So you have 2 outside, right? Then we take a derivative of this. So you drop 1 level for that, right? So that would be, okay, I'm going to take a derivative of that. That would be 2, 15 minus 0.001 P, drop 1 level is 1. However, the inside is not just a P. You have more complicated situation. You need to do the chain rule. That would be negative 0.001. You better know how to do the chain rule. Otherwise, you cannot do the problems, right? Then we multiply them out. It ends up like this. Let me see, do I have typos? Just want to make sure. Okay, so we will have this one. Okay, you can do that. So your D prime P is this guy. Okay, so we put in here negative 0.06 plus what? 0.00004 P. Okay, right? So that's our elasticity of demand according to the price. That's our E value. Then what's the question? We want to find out E value is bigger than 1, smaller than 1, or equals to 1, so we can decide what to do, right? So how do you find your E value? You have a starting point is what? Here, $12,000. You want to go from there up or down or remain the same, right? That's your P. So you need to plug in your E with 12,000 into that equation, right? So you will have 12,000 times negative 0.06 plus this big small number 0. Be careful with your zeros, right? So you don't have typo much that way. Then you plug in 2 times 15 minus 0.001 times your 12,000. Then take a square. Then use your calculator, right? So that would be 144. Make sure you get the right number. So that would be 8. Bigger than 0 or smaller than 0? Bigger than 0? Bigger than 1, what I mean. Okay? Bigger than 1 or smaller than 1. So that would be this case. So it means what? Lower the price will help or not? Will increase the revenue. Right? That's what we have been learning about the E, elasticity of demand, to help us to analyze the situation, right? Price is given, sometimes you have this thought, but the demand quantity according to the price, this guy is very hard to combine. It's not that easy to have those functions available to you. Then you have to do more advanced study and for your economics, right? To develop these kind of things, and by working experience and data to help you to sort it out, to find a function which is realistic and working. Okay? One more thing will be on your test. It's about interest and depreciation. Okay? So let's practice some more. First one, about interest. A bank account grows at what? 7% compound continuously. Okay? The question is, how many years will it take to double? First, we'll try to figure out how long it takes you to double your money and when you can get more money by 25%. Okay? So we wanted to find the time frame for those. If the account grows at 7% per year, right? Compound continuously. So remember your formula for the compound continuously? Formula is what? FV, future value, equals present value. Use the exponential equation, right? RT, right? R is your annual rate, T is your time, then T is your variable. If your variable is at exponential position, that means you have exponential function. Okay? When it will take you to double your money? And when it will take you to, you know, have quarter more of the money, right? Let's see. You just plug in, right? So future value, if double, that would be 2p, right? The PER is what? 7%, 0.07. T is your variable, right? So all you need to do is to solve your exponential equation. Divided by P, right? 2 equals 0.07t. Simple exponential equation. How should we solve it? You can rewrite it as what? The log, right? We say for this, so you will write a what? Log base E. Which one you put it in the middle, which one you put outside. So you hook this way, hook to your power, then to the inside, right? So this one is a natural log 2 equals 0.07t. So how do you solve your t? Then you plug into the calculator for the natural log 2 divided by 0.07. So your t is about this one. Oops, 9 point, you do it, right? 9.9021. So it would be about, say, 9.9 years, right? Then how long it takes to get 25% more? That means what? Use this one. The original is a P. So, oops, original is P. Then future value will be what? 1.25p. Is that right? So we do the same thing, right? So you will rewrite it. So 1.25 equals e to the 0.07t. That means what? Natural log, like here, natural log 1.25 equals what? 0.07t. Right? Then your t would be natural log 1.25 divided by 0.07. So your t is about 3.1877. So it would take you how many years? 3.18 years to get a quarter more, right? So you need to know your money. Okay, if you work for banks, then those are basic things you need to know. Next one, rate of return. An investment of $8,000, okay, grows to 10,291.73 in 4 years. So either you work for the banks or stock market, then or brokers, as a broker, then if your investor says, okay, he started from $8,000, 4 years later he has 10,000 some more dollars, right? Then he was wondering, what's my rate of return? So a lot of time you see some data, then all the different funds have different returns. That's how they calculate, right? For different investment funds, they show you different numbers. So they start from some numbers and end up in 4 years. Then they say, oh, what's the rate of return in these 4 years from here to there, right? So they if we wanted to find the annual rate of return for annual compounding, okay, so they use what? Annual compound rate, the method to do that. Okay, remember your formula for compound formula. It is what? Your future value is your principal times 1 plus the annual rate to the how many times per year to the what? Total compounding time, right? That's the year is T. This one M is how many times per year. That's your R. So for this question, if we compound, when we calculate investment rate, usually we will do compound annually. Okay, so if it is compound annually, it means what? Your M is 1, right? So let's plug in your F. Future value is 10,291.3. Your principal is 8,000. 1 plus R. Do you know your R? That's the number we are going to find out, right? T is what? What's your T? Actually is in 4 years, right? So your T is 4. So the things we are going to find is not the exponential position, not like those, right? It's one of the base. So it's a little different skills to solve, right? So what do? Find your R. You get rid of everything else first. Then you wanted to use all the decimal you can, probably, but not use cell phone. That would take forever, too many. So probably 8 or 9 decimals. That would be good enough. Then how you are going to solve this? You need to know how to solve the equations, right? That's why we reviewed in the first week. So it's the 4th power. What do? You will take 4th roots, right? So this cancel out. Then you will use your calculator to do the 4th roots. How do you do the 4th roots on your calculator? You don't have that thing, right? So you will do this, right? Do the power, because this one you can write as what? Quarter power. Is that right? 1/4 power means what? 4th root. So you will use calculator, type in as such to the power of what? 1/4. Remember to put a what? Parenthesis around for your power. Otherwise, only power 1, then divided by 4. It's different from taking the 1/4 power. That will be your 1 plus R. Okay? Then you will find out this number should be 1.0649999979. You better do it yourself. Okay? Because for the exam, I will not tell you the answer. You actually have to punch in, right? So your -1, so this is this. Then your R would be what? -1. So R is about -1, right? That would be 0.0649 something. So it's about what? Here percentage, right? Would be 6.5% to here, right? For percentage rate. pretty straightforward. You should be able to do this in no time, right? You need to do that for business major. So that would be our review. You need to study those. Your exam would be similar to those. May not be exact. Are we good?